Okay, let me give you a couple more examples, okay? But before starting next example, but like keep that in mind, as I told you in live class, and even I'm gonna try to show you how we can derive Laplace transform by the definition, but after this section, we are not gonna do this again, okay? Because we did everything already, and I gave you the Laplace transform table on the very end page of this lecture note, okay? And which is here. I'm talking about this guy, okay? And here, like we just talked about the first one, when function is equal to 1, then your Laplace transform is 1 over s, okay? And like all these are given, then to solve the like differential equation, we're going to use like this table, okay? We don't have to like derive every single time, okay? And now next example is constant with number 2. And we're going to try to find Laplace transform of this function into the AT exponential function, okay? Then my answer must be 1 over s of a, okay? Let me come back to example. Here we go. Okay, we will do same thing, okay? So Laplace transform of given exponential function is equal to, by the definition, is integral 0 to infinite e to the minus st times e to the at dt, okay? So let me simplify a little bit. It is equal to, let me combine two separate exponential functions as one single one, okay? Integral 0 to infinite e to the minus st plus at dt. Then also we can write this one as, let me take negative t out. Okay, it might be better to write like opposite order. It can be written by minus s minus at dt, okay? Then we are ready, okay? By the definition of improper integral, it can be written by 0 to a e to the minus s minus at dt, and send your a to infinite, okay? So antiderivative of your exponential function, which is 1 over minus s minus a e to the minus s minus at, and we're going to plug in 0 and a into t. Is okay? So, okay, since like 1 over minus s minus a is coefficient, we can write this one in front of your limit, okay? So 1 over minus s minus a, limit my capital A goes to infinite, and plug in a first, which is e to the minus s minus a, and minus e to the 0, which is 1. Does it make sense? So now it is same thing, okay? And like if your power of exponential function is positive, and it will be diverse, which means there's no meaning, okay? So we're gonna think about like this whole thing, minus of s minus a times a, negative, I mean like minus of s minus a is negative case, okay? So in other word, when s minus a is positive, then this will be e to the minus infinite, which is equal to 0, okay? So since this equals 0, by like take the limit, it is equal to 1 over s minus a when s minus a is positive, or we can say s is bigger than a, okay? And this is a way to like derive your Laplace transform of exponential function, okay?